Hello, welcome to a new lesson. Today we're going to learn about the dot product, aka scalar product, or sometimes called the inner product. So this goes by three different names depending on the textbook that you're learning it from. Most common name is dot product, but I felt like I should tell you the other two names just in case you move on and it looks a little bit different. The dot product, A dot B, is the magnitude of A times the magnitude of B times the cosine of the angle in between. And that's when they're placed tail to tail. So if we have a setup, two vectors are placed tail to tail. Theta is the angle in between. Now the dot product is how we one way that we can multiply vectors. But multiplying vectors doesn't make a lot of sense. But when we do that, we get this thing called dot product. Every year, students are a little upset when I first tell them that this number doesn't mean anything in particular in this physical drawing. There's no place where I can show you where the dot product is. However, the dot product is useful in order to find certain things about this. For instance, later on we'll see how the dot product helps us find the angle in between two vectors. Now first, let's do basic things like find the dot product. So A dot B is going to be the magnitude of A times the magnitude of B times the cosine of that angle in between. Magnitude of A is 5. The magnitude of B is 8, and the angle in between is 35. So you go to your calculator, type in 5 times 8 times cosine of 35, and your answer should be 32.766. Now what kind of an answer do we get? Now this is a scalar answer. It doesn't tell us much other than that it's positive. And it doesn't tell us much about this diagram yet. Let's do this one. A dot B is the magnitude of A times the magnitude of B times the cosine of the angle in between, which is 115. Oh, I forgot. I should have put theta there. This is 5 times 8 times the cosine of 115. So this is going to be 40 times the cosine of 115. So now this answer is negative 16.905. That's what A dot B is. So now A dot B is negative. Now why do we get a negative answer here? Well, the cosine of 115, cosine in quadrant 2 is always a negative number, so negative times 2 positives is going to be negative. So that means that anywhere between 90 and 180, the dot product is going to have to be negative. So there's some special cases that we need to look at. Vectors, when they're going in the same direction, if we put, it would be cosine of 0. So the cosine of 0 is 1. So A dot B, in this situation, it's going to be 40, because it's going to be 5 times 8 times 1. If they're going in the opposite direction, cosine of 180 is negative 1. So it would be 5 times 8 times negative 1. So in this situation, A dot B would equal negative 40. Now, if the vectors are perpendicular, the cosine of 90 is 0. So 5 times 8 times 0, A dot B is going to be 0. So the greatest value that this could be with 5 and 8, your dot product could be 40. The least value it could be is negative 40, where right in between there, it will be 0. So if we find the dot product of this, before we even go further, we can look at this and see, we can answer if the answer is going to be positive or negative. Since that's acute, our dot product should be positive. So A dot B, it's going to be 12 times 7 times the cosine of 40. So 12 times 7 times the cosine of 40. I get the answer of 64.348. That's A dot B. Pretty easy. If I want to use the dot product and the magnitudes to find the angle between the vectors. Well, we know A dot B is equal to the magnitude of A times the magnitude of B times the cosine of theta. So if A dot B, if we know that's 58, the magnitude of A is 4, the magnitude of B is 19. Now I have to multiply 4 times 19 to get 76. So 58 is going to be 76 times the cosine of theta. Divide 76 on both sides. We have 58 76, which is 0.7631. Now I want to take the inverse cosine of that answer, and theta will equal 40.257. Now if we look at this previous problem, alright, that's completely different, so that doesn't help us out at all. Alright, let's keep on rolling. Now if we have the same situation, you try this one and see if you can find the angle between these. Since the dot product is negative, we know that the angle has to be obtuse. Alright, so we start with the formula. This is negative 110 times 9 times 15 times the cosine of theta. 9 times 15 is 135. So if I divide that on both sides, that's negative 110 divided by 135. To get negative 0.8148. And when I take the inverse cosine of that answer, my theta is going to be 144.569. So that's going to be the angle between my two vectors. Alright, now if I want to find A dot B here, I have 1i and 4j, so and 5i and 2j. So this is going to be my B. This is going to be my A. A dot B, we need to find the angle in between here and find the magnitudes of both of these. Alright, so our first step is to find the magnitudes. The magnitude of A is going to be 5 squared plus 2 squared, and then square root that. So that's going to be 29, so that's the square root of 29. The magnitude of B is 1 squared plus 4 squared, which is going to be 16 plus 1, which is 17. So root 29 times root 17. Now we need to find the angle in between here. Now that gets pretty tricky. How do we find the angle in between those? There's a few different methods. What I'm coming up with first is we could find this side here and then use the law of cosines. Or we can draw this side down, find this big angle, then find this other angle, and subtract them. That might be the easiest, because this is 1, this distance is 1, 2, 3, 4, So if I take the inverse tangent of 4 over 1, this big angle, let's do this in green. This big green angle is 75.963, because tangent of, what should we call it, phi is equal to 4 over 1. Inverse tangent would give you 75. If I want to find this alpha tangent of alpha, that will be 2 over 5. So if I take the inverse tangent of 2 over 5, alpha would be 21.801. So if I subtract those values, 75.963, actually it should round it to 964, minus 21.801, our angle there is going to be 54.163. Alright, so now we have the two values and the angle in between. So I can say root 29 times root 17 times the cosine of 54.163 is going to be A dot B. So if I calculate this, root 29 times root 17 times the cosine of 54.163, I get times 22.2, I get 12.997. So this is essentially 13. A dot B. Alright, so 13 for my A dot B. Now we want to look and see if there's a way that we can get 13 just by using these. Well, 5 times 1 is 5. 2 times 4 is 8. And if I added them together, I would get 13. So there's a way to get A dot B without going through all of this work. We can just do 5 times 1 is 5, 2 times 4 is 8, add them together, and you get the same answer as going through all of this. It's really nice because now there's two methods for finding A dot B. So if I want to find the dot product of a three-dimensional, we do the same thing. 4 times negative 6, which is negative 24. 3 times 4 is 12. 7 times negative 9 is negative 63. Add those up. Negative 24 plus 12 minus 63. A dot B is negative 75. Now what this tells us is we know that these two vectors have to be form an obtuse angle between them. So they're kind of going in the opposite directions. That's what we can tell from the dot product. So let's find the dot product of this one. Pause this and start it back up once you got it. Well, if I do A dot B, 5 times negative 2 is negative 10. 1 times 7 is 7. Negative 9 times negative 1 is positive 9. So if we add these all up, we're going to get to 6. Alright, so A dot B is 6. Wonderful. Now let's find the angle between these vectors. So that's this one where we found out that A dot B was negative 75. So if A dot B is equal to negative 75, let's find the angle in between. We know A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle in between. A dot B is negative 75. Let's find the magnitude of A. 4 squared plus 3 squared plus 7 squared. And then square root that. So we have 4 squared plus 3 squared plus 7 squared. So this is going to be the square root of 74. The magnitude of B, I don't know what that line is there. We do Pythagorean theorem again for 3 dimensions. and is the square root of 6 squared plus 4 squared plus 9 squared. So 6 squared plus 4 squared plus 9 squared, that's 133. So this is going to be the square root of 133. So A dot B is negative 75. Magnitude of A is root 74. Magnitude of B is root 133. Now, when we find the value of our theta, first I'll multiply root 74 times root 133. So I have negative 75 is equal to 99.207. Divide both sides by 99.207. And we have negative 0.7560. Now if I take the inverse cosine of that answer, theta is equal to 139.11. So this says round to the nearest degree, so 139. So it's about 139 degrees between these two vectors. Now let's do it, find the angle between these two vectors. Now we've previously done that and found that A dot B was 6. So we know that there has to be an acute angle between these two. A dot B is 6. Now pause this and see if you can do this on your own to find that angle. Alright, to find the magnitude of A, we take 5 squared plus 1 squared plus 9 squared. And we take the square root. To find the magnitude of B, we take 2 squared plus 7 squared plus 1 squared. And then we take the square root. So this would be 25, 26, 26 plus 81. This is the square root of 107. And this other one is the square root of 54. Now we could simplify this to be 3 root 5, or 3 root 6, but we really don't need to deal with that right now, because 6 is equal to root 107 times root 54 times the cosine of our angle in between, and the square root of 107 times the square root of 54 is 76. So 6 equals 76.013 times the cosine of theta. 6 divided by that answer is 0.07. So cosine of theta equals 0.0789. And the inverse cosine of our answer, theta is equal to 85. It says nearest degree, it was 85.4, so let's just say 85. Now before we even started this problem, I had a fairly good idea that this was close to 90, because our A dot B is really close to 0. Remember, if A dot B is, or if the angle is 0, it would be these two numbers multiplied together. If it's 90, it gets closer and closer to 0. So 6 is pretty close to 0, so that was a little indication. Alright, now that's that for this lesson. So here's your homework. Good luck.